In Lesson 2 of Chapter 5, we're going to talk about writing our first console application program. And the first thing we need to talk about is the structure of a console application program. There's a couple ways you can write such a program. One of them is in the IDE. There is an IDE subsystem of console application, and the nice thing about writing it that way is you'll get a lot of help. You'll get the automatic fill-ins, and you'll get the different coloring for different types of statements, and things like that. But I almost never do it that way. Maybe it's habit or having come from a time before there were IDEs, but I almost always write a console application in Notepad and just look things up with Google when there's something I don't know how to do. So an example of such a program would be our usual first program of Hello World. And you'll notice that slashes are used for comments, as usual, the same as with Windows applications. And then the first real statement is public class hello. And we've talked a fair amount about classes and namespaces. Namespaces are basically libraries of classes. And there's actually two flavors of classes. There's static classes, which are sort of their own thing. And this is really an example of a static class, although we don't qualify it as a static class. Don't have to, because further down we qualify the method as a static method. But the static class is just meant to be its own thing and run in its own way. It's like the old classic programs before we had classes, really. And a dynamic class is one that in a way doesn't exist on its own. The only way you can get a dynamic class to exist is by instantiating it as an object. That's the main difference between static and dynamic. And if you want it to be dynamic, you just don't say anything. You don't have to specify static. It defaults to being dynamic. But so we have our public class, and then we have a brace saying the beginning of the class, and then a brace down here is saying the end of the class. So everything's contained within this class definition. And then in the case of this program, we just have one method, and this method has to be named main, as far as I know, because it's going to, when it's a standalone program, it's going to look for a method named main as being where it starts running. So we have public static void main, and the void basically is the return value from a function. And we could return something. Instead of saying void, we could say int. And then within the program, at the last statement of the program, we could say return 1, 2, 3. So whatever called this method would receive a return value of 123. But we don't want to actually return anything. So instead of saying int up here for what the function returns, we just say void. And public is what's known as an access specifier. There's actually 3 levels of access specifier: public, private, and protected. And it's really beyond the scope of this lesson to talk about that, but essentially public means it's totally accessible by the calling program, which in this case there is no calling program. It's just being called from a Dosbox or a command prompt window. It's a standalone program in effect. And then we only have one real statement in the program, just like the original Hello World program we wrote as a Windows application. And that's system.console.out.writeLine, which is the method name, with a parameter passed to it of a string delimited by double quotes and all this before the method name of writeLine are namespace and class identifiers. And it actually doesn't matter that much whether it's a namespace or a class in terms of what the user has to type in, because it'll look the same whether it's a namespace or a class. I can tell you for sure that system is a namespace, and probably system.console is also a namespace, console being a namespace nested inside the other namespace. A namespace, as we've said before, is a container for putting classes in. It's a way of organizing classes so that we have a lot of classes that are related to each other and we put them in the same namespace. And then out is probably a class, I suspect, within the system.console namespace. And there's actually, you can leave that out and it'll work. You can say system.console.writeLine and it'll work too. And this is what's known as a fully qualified name. We're specifying all the namespaces and all the classes that we have to go into in order to find the writeLine method. Instead of doing this, what we could do is take this system and move it up here and use a using statement. And then we go down here and get rid of the system. And because of the using statement, the compiler knows to look in this namespace for another namespace named console and find this. And we could in fact take this out too. Put it up here. Get rid of this dot, of course. And then it would be able to find out.writeLine in the console or the system.console namespace. So the using statement is very useful. It saves you a lot of typing and of really long fully qualified names, and it's used a lot. In fact, if we compare our console application to our Windows application, you'll notice there's a ton of using statements here. And system is sort of like the namespace at the heart of the universe for C#. Everything in the world is in the system namespace, and then there's a lot of qualified namespaces, or nested namespaces within the system namespace. And in fact, it says that whether it's a nested namespace if you put your cursor over it. I didn't even realize that. These are all namespaces. Namespace system.txt. Most of these aren't even used because we only make one system call. We could have gotten away with deleting everything but the using system. But all of this was generated for us automatically in anticipation of our using a lot of other things when we wrote the program. So that's our Hello World program. And one of the differences you'll notice is between the class that's specified in this program is that there's a partial qualifier. And the significance of the partial qualifier is that it's saying this is only part of the class. I have another source file somewhere that when you compile it, put it together with that source file in order to get the complete class. And in the case of this, the rest of the source file is written by Microsoft. So Microsoft's going to add a bunch of functions to the function you're created in order to have a nice, complicated window interface that's simplified for you. They're writing most of the classes, so that's why this is partial when you write a Windows application. And then of course in the Windows application we create a namespace also, the namespace with the name of the program we're creating. So we could have multiple classes, and I'll show you later on in more advanced lessons how to create new classes within this namespace that's generated for us automatically when we generate the code with the Windows application and the IDE. Alright, so we've gone in with Notepad and we've written this nice old application that's in the correct format with the public class enclosing everything, and then a method called public static void main, which has to have that name, so it has the system has a hook that it knows where to start the program. And we've called this Microsoft function write line, or method within a class, and it prints out hello world on the screen. But where does this run? The way you have to run it is within a Dosbox, and there's a way of getting to a Dosbox from the start button, but I couldn't for the life of me find it. I originally copied it over to these nice toolbars I use all the time. Like this is the Dosbox in my toolbar right here, and I just click on that. Another way you can bring it up is you can click on Start and go to Run, and then you can just type in CMD, and that'll bring up a Dosbox, as you can see here. But whatever method you use to bring up a Dosbox, another thing you can do is establish if you know how to modify the folder options, you can put a command on folders to add an additional command, which I call command prompt here as the name, and just right click and select command prompt here, and it'll put you in a Dosbox right in the right directory. But to just expedite matters, here's my Dosbox, and it's already in the right directory that has the program we've been looking at with it. If I do a dir, which is the command for directory, we see the program, which is hello.cs, and the hello.cs, the .cs has to be specified in order to say it's a C# program. It won't be processed right unless you say .cs. And if I do like n, my alias for Notepad, and hello.cs, it brings up the program we were looking at. So that's all. We need to take it from something readable by a human and translate it into something a computer can execute. And in order to do that, we need to use the C# compiler that comes with the system. It's all. If you have XP or Vista, you already have this compiler. You don't have to download anything. And the name of this compiler is CSC. So if you say CSC space hello.cs and type enter, ta-da, magically this compiler comes up and translates your human readable program into zeros and ones the computer can execute. And if we do another directory listing now, we'll see we have two programs, hello.cs and hello.exe. And of course the exe is the executable file. So if we type hello, it'll run the exe, and there we have it, hello world, printed out to the command prompt or the Dosbox. So that's the first step in writing our usable program, is how to write the basic program for a console application, since the program we're writing ultimately will be a console application. So let's see. We got invoking the Dosbox, although I couldn't find it on the start button. I know it's there. I may have actually moved it off the all programs on the start button when I started making all these copies of it. So that's done, and compiling the program is done. So it looks like that completes this lesson. I'll see you in lesson 3.